Hello, Miss Welsh here. So today we're going to do day 5, calculus with geometry, applications of calculus. So we'll use some geometry with these problems. Okay, so we've got a greenhouse is made in the shape of half a cylinder. It is constructed from a galvanized steel frame with a multi-wall polycarbonate sheeting. The steel frame consists of a rectangular base and 4 semicircular arches. Okay, and then 3 further support rods. Okay, so then here, these are going to be our 3 support rods. Be careful, like internalize all the information first, and then here we have 4 support arches, so that'll be important soon. Okay, the semicircular arches have a radius of r and the supports have a length of L. Okay, write down the expression of S in terms of r, L, and pi. So that means those are the variables that you're going to have in your formula. And S is the total length of steel. So it's all the rods together. All right, well, first of all, we're going to need this. And then can you see that we have 4 of these, right? And so actually what these are going to do is these are going to make 2 full circles, the arches, okay? We're going to need the circumference, and the circumference in your formula booklet is 2 pi r, okay? So first of all, the arches are going to be, this is for full circle, and we have 2 of them, so this is going to be 4 pi r, okay? So that's the arches. What do we have next? We have this front and the back. So if this is r, then this is r plus r, so this is 2r. You also have 2r in the back there, so then this is going to have, this is going to be 4r. Okay, so this is going to be the front and the back. Front and back. And then the last thing we have is the L. So this is L, and then this is L, this is L. So this is 1, 2, 3, 4, 5. So you have 5 L's altogether. Ta-da, here's your formula. Wonderful. Okay, so that's A. I'm just writing it up here because we're going to need some space. Okay, the volume of the greenhouse. So remember, this is going to be an optimization formula. They like to do this. They like to give us this helper function that you then isolate for. The volume is this. Write down the equation for the volume of the greenhouse. Okay. What is this? This is a semi-cylinder. So if you look at the volume for the cylinder in your formula booklet, then it's pi r squared h, right? Because this is your cross section and then multiplied by how high it is. So what we have is we have half a cylinder, and instead of h, this is our height. So I'm just going to use L, okay? So we're going to have pi r squared L over 2. And we know that this is equal to 37.5 pi r squared L over 2. What did they ask for? They asked for the equation of the formula, right? Okay, so now you know what this is going to be, right? This is going to be those show that questions that this is actually the, that this is just in terms of r here, yeah? So you can see that here you have just r, right? Pi is just a constant. But here we have a problem, right? We have this L as well as r. We can't use 2 variables. You know what we do in this case, right? So we're going to isolate for L. And then once we have that, we're going to substitute that expression by, in. Okay, so this is going to be 75, and this is going to be pi r squared L. And then we're going to divide both sides by pi r squared. Shwoop, shwoop. Okay, and so now this is nicely going to travel up and go in there. Okay. So let's do this, and then keep your eye on the prize. Hopefully, we get to this expression. That would be awesome. Okay, so first of all, we have the 4 pi r, and then we have the 4r, and then we have the 5, and then we have 75 over pi r squared. Okay, so this is not bad, right? Because this has been like factorized out. So look where we're going with this. So this is going to be 4r, and yay, 5, multiply 5 times 75, and you'll see that it's indeed 375. We've got the pi r squared on the bottom, so we're happy little campers. The only thing that's been done here of why it's different, and you would need to make this step as well, is remember your common factoring. Can you see that they actually have factored out the 4 and the r, okay? So we have 375 over pi r squared, and then we have 5 plus 4r, and then 1 plus pi. Ta-da! There it is. Boom, there it is. Boom, there it is. Beautiful. Okay, so now let's move on to D. So remember with these questions, that was the most difficult part of the question. It's very possible that you're not able to arrive at it. Remember, it's important to have those skills of not giving up and just moving on, okay? So you can still derive this, even if you didn't get the previous part. Otherwise, when people give up on these 15, 17 mark questions, they die. It kills their whole paper. Okay, and then you have 4r plus 4 pi r. First thing to do, as soon as you see the r on the bottom, I know this is tricky, don't touch the pi, okay? So this is not the derivative yet, just leave the pi on the bottom and drag this up, okay? And so now we're ready to derive. Also, be really clear with yourself with notation, like this is just my s, this is still my s, now this is a derivative of s with respect to r. Okay, drop the minus 2, so this is going to be minus 750 over pi, r minus 1, so this is going to be minus 3. The derivative of 4r is 4. The derivative of 4 pi r, remember pi is just a constant, is 4 pi, and that's your derivative, okay? The greenhouse is designed so that the length of the steel is to be minimized. Show that the r, for which s is a minimum, is 2.43, okay? So they're looking for you to be aware that when it's the extremum, minimum max, that this is equal to 0. So even if you have no idea how to do anything else, just write this step down, okay? So we're actually now just going to do that. So minus 750 over pi, dum-da-da-dum, we need to solve this. This is a check mark, by the way, not an R. I was just proud of myself. Okay, and then this is 4, and then this is 4 pi, okay? So what we can do is let's just graph this. Let's throw the derivative in, minus 750 over pi. Now, of course, you could show this algebraically, but for the love of God, don't. So, plus 4, and then plus 4 pi. And then you want to get a nice graph here. And then what did they want? They wanted, so try the auto scale. Maybe it'll be something nicer. Oh my God, that's awful. So then just go from, I don't know, what the heck is this, honestly? So just try like, I don't know, minus. Well, you don't even need the minus. You're not even interested in those volumes. Okay, there you go. Whoa, Miss Walsh, woo. Yeah, so now what we're going to do is we're going to go function, root. There it is. Beautiful. Let's draw that graph, right? Remember, it's a show that, so they're looking for that absolute clarity. And then just draw this. This is R. This is ds, dr. So it's here, and then this is 2.43. And so then now you can say that you showed it, and then you have this understanding on how to do that, okay? So graphically is okay. Calculate the value of L that gives that, okay. We have an expression for L somewhere up here, don't we? So L is 75 over pi r squared. So L is 75 over pi r squared. What you can do, remember, unrounded values are better than the rounded. Just go to Shift, copy, and then just copy that x value, okay? And now you've copied the whole thing. And so now you can do 75 divided by pi, and then r, nope, Shift, paste. There it is. And that'll give you a nice and exact answer. And then you also look, you know, very knowing with the examiner. Like on the paper, put ... okay? And so then you have 4.03. That's your minimum. L. Good. Okay, and so now last thing, almost done. You have the minimum L, you have the minimum this, and now it just wants the area, the minimum S, the minimum rod. So you can just substitute this into the expression. You can substitute the R, you can substitute the L, or like you don't have to. What you can do is just graph the function. So there's a couple of ways to do this problem, and then just go here. I already have it graphed, so that's I'm trying to make the videos as short as possible. Get a nice graph, and even if you didn't know how to do like anything else, so let me just try an auto scale here. Okay, that's horrible. Just again, remember looking at the num is always nice just to see, okay, what are my numbers like? Okay, 62, whatever. So if the auto scale is failing you, then nobody needs 92,000. This is very nice, right? Don't ever graph the negatives. You don't care about the negatives. It's not relevant. If the examiner is really annoyed, they can even take off mark for you working out of context. Okay, and then what you have is you have extremum. Of course, there's the minimum R, and so what you have is you have that the minimum area. Those are units here. We should really be good with the units, okay? Because sometimes they will make a unit penalty as well. And this is not squared or cubed because it was just the rod length. So basically, what did you like answer? Oh, by the way, how many marks is this? It's 2. So, you know, just kind of make this graph. And now we've graphed the actual original. And this is the R. Yeah, what is it that we did? Just to put it back in context. Like there's a different way you can do this. Okay, okay, bye.